Okay, so today we're going to go over a couple of ways of factoring. But before we do that, we want to make sure that we have the right background information. So the first thing we want to go over is the polynomial. Now, a polynomial is a collection of terms with addition and they have variables. In this example particularly, we're going to be working with a trinomial, which is a polynomial that has 3 terms. The other terms that we want to know are like terms, which is when the variables have the same power and that we can combine those. We also want to know our general form, which is ax squared plus bx plus c, where x is a variable, a, b, and c are all constant. The other things that we want to know is why we want to factor and what factoring actually is. So factoring is breaking something into smaller, less complicated parts, and we want to do this because if we're given some really long, messy equation, it's not going to have any significant meaning to us. However, when we start to break it down, we can start using those smaller pieces to figure things out. The other things we want to remember and pull from are the greatest common factor, which is the largest factor that terms share in common, and the FOIL method that we went over previously is going to come in helpful here. So the 2 methods we're going to go over today are going to be the AC method and guess and check. The AC method, we want to start by combining like terms and putting it into general form. So if we look at our examples, the first one we had 9x plus 5x, and we went ahead and simplified that to 14x. We also had negative 2x squared plus 2x squared, and those terms ended up canceling out, and we were left with 9x plus x, which is 10x. And then our last one, we had 2x squared plus 2x squared, which gave us our 4x squared. And then we had 12x plus 22x, which gave us 34x, and we brought our 42 along. However, this is going to be the example that we use for the rest of this problem. The next step is we want to make sure we pull out any of our greatest common factor of the 3 terms. So what we're going to do is we're going to look at the prime factorization of each. So the prime factorization of 4 is 2 squared, the prime factorization of 34 is 2 times 17, and of 42 is 2 times 3 times 7. Now if we look here, the only things that these actually share in common are going to be a 2, so that's going to be our greatest common factor. So what we want to do next is go ahead and write our 2 down, and we're going to open a set of parentheses. And in that parentheses, we're going to write down what was the remaining in each term after we pulled that 2 out. So for the first one, we had 2x squared. The second one, we had 17x. And the last one, we had 21. And then we go ahead and close off those parentheses. The next part is to make sure we identify our a, b, and c from our general formula. So our a is going to be the value in front of our x squared. In this example, it's 2. And b is in front of our x, which is 17. And c is going to be our constant number, which is going to be 21 for this equation. For the AC method, the next step is going to be to multiply your A and B, or your A and C. So we're going to do 2 times 21, which gave us 42. And our next step is to find 2 numbers that are going to multiply to 42, and we want them to add, or they could subtract to B. So for this example, we want 2 numbers that multiply to 42 and are going to add to 17. We already looked at all of those numbers, and so we're going to look at all of them and pick the one that gives us 17. However, for every example, you're not going to have to calculate all of the options. You're just going to want to calculate the ones that are going to be close to it until you find the right one. So for this example, our correct answer is 3 plus 14, and that gave us 17. We want to remember that it was 3 plus 14 because we're going to use that as we break apart b into 2 different terms. And we're going to use that 3 and 14 as our coefficients. So if we look here, we had 17x, and 17x is going to be the same thing as 3x plus 14x. And since it is the same, we can go ahead and substitute them in, and that's how we get this new polynomial. Then we're going to go ahead and group the first 2 terms and the last 2 terms together, and we want to make sure we pull out any greatest common factor that those 2 share. So for the first one, we had 2x squared plus 3x, and 2x squared is just 2 times x, and 3x is just 3x. So the only thing that they share in common is an x, making that our greatest common factor. And again, we're going to write our greatest common factor, open parentheses, write the values that are left for each term. So the first one was 2x, the last one was 3, and then we go ahead and close the parentheses. As you can see over here, we did the same thing for the last 2 terms, and we got our greatest common factor as 7, so we had an answer of 7 times 2x plus 3. The next step is to go ahead and substitute those back into their corresponding spots. Once we make that substitution, we can go ahead and see that we have 2 new terms here. And we're going to look at those 2 new terms and pull out their greatest common factor as well. We can go through the steps the same way that we did before, but we're going to see that the greatest common factor should just be that 2x plus 3. So we want to pull that 2x plus 3 out, and we're going to go ahead and open more parentheses. In that first term, once we take out the 2x plus 3, we're left with an x, so we put our x down here. In the last term, we're left with a 7, so we have our 7 there. We can go ahead and substitute that in, and we're going to get our 2 times 2x plus 3 times x plus 7. And this should be our final answer. However, there is still going to be one more step. We want to make sure we go back and check our work. So we're going to go back ahead and FOIL through our two polynomials, and we come up with this. And then we combine our like terms and redistribute, and we find out that our answer ended up being the same. So our 2 times 2x plus 3 times x plus 7 actually ended up being the correct answer. And it should almost always be the correct answer. The other option that we have is to do guess and check. And it's going to start off the same way as the AC method does. We want to go ahead and combine our like terms. Once again, 9x plus 5x is 14x. Here our x squared is canceled out and we're left with 10x. And down here we ended up with an answer of 4x squared plus 34x plus 42. And again, we want to make sure we pull out our greatest common factor. Again, 2. We're going to go through this step again just to make sure. We want our greatest common factor in the front. We open a set of parentheses and we write what's left for each term. So for our first one, we had 2x squared plus 17x plus 21. The next thing is we want to write down all of the different combination of multiples to give us 2 and 21, or our a and c. So for a, it ended up just being 2 and 1, and c we had 1 and 21, or 3 and 7. Once we have all of those written out, we're going to go ahead and start trying combinations and seeing which ones we can get to give us our answer for B. So what we want to do is we're going to go ahead and take each number and multiply it by one of the numbers in C. So for example here, with A being 2 times 1 and C being 1 times 21, we have the options of 2 times 1 equals 2 and 1 times 21 is 21. However, when we add those together, we don't get to our 17. And we could also flip places, so we could have done 2 times 21 or 1 times 1, but again, we still don't get to our 17. So we're going to go ahead and try 2 times 1 and 3 times 7. So once we try those, we could do 2 times 3 and 1 times 7, but that only gives us 13. And if we did 2 times 7 and 1 times 3, we actually got to our 17, so that's going to be our correct answer. So we want to make sure when we write out our equation, we have our 2 times our 7 and our 1 times our 3. So the next step is to go ahead and decide on a position and sign. So whenever we are doing the guess and check method, we're always going to start with 2 sets of parentheses, and we're going to go ahead and fill in the information. We want to make sure we put our x's first, and we're going to put the values that we decided for A, and it shouldn't matter which order in front of our x's. So we have our 2 here, and there's an implied 1 here as well. And the next step is to decide where we want to put our values for C, and what signs we need to put in the middle. So we have a nice little checklist here that'll help us decide where we want everything to go. The first thing we want to do is look at whether C was positive or negative. Here we can see it was positive, and since it's positive, we know that our signs are going to be the same. If it had been negative, we would be looking at things where signs are opposite. So we can go ahead and cross off all of those. The next step is to see whether or not B is positive or negative, and this is going to tell you where you would need your signs, and particularly which signs you need. So here, since B is positive, we want both of our signs to be positive. If this had been negative, we would want both of our signs to be negative. So we can cross off these two. And then we wanted to make sure that we put our 7 and our 3 in the correct places. And we said we needed our 2 times 7 to give us our 14. And when we FOIL, we know that we multiply the outside and the inside together to give us our middle term. So we want 2 and 17 to either both be on the inside or both be on the outside, and we can realize that that's where this one comes in. So we can go ahead and cross off that answer, and our answer ended up being 2 times 2x plus 3 times x plus 7. We could go ahead and FOIL that back out and double check just to make sure. When it comes to guess and check, there's a lot of little hints and clues that can help you along the way. And if you watch this video, we can go ahead and see some of the good examples of the hints that are commonly used. However, if you do ever come into a polynomial that has tried everything and you just can't seem to factor it, that's okay, because it is going to be true that some of our polynomials are impossible to factor. Actually, a decent chunk are impossible to factor when it comes to real numbers. So don't worry if you come across something scary. There still might be a few scary ones out there, something that can't be factored, and that's okay. Just make sure that you write that it is unfactorable or prime. And that's how we factor.